Welcome back to Scienteens. Today, we're joined by one of India's most respected nuclear physicists and engineers. He is the recipient of dozens of scientific awards during his career, the most prestigious of those being the Padma Sri, Padma Bhushan, and Padma Vibhushan. Yes, we're talking about Dr. Anil Kakodkar, the nuclear champion of India. And today, he'll share some expert insights onto the future of this field in our country and across the world. Before we get started, be sure to hit the like and subscribe button so you can keep seeing content like this. Let's get into it. So, let me start by asking you, what made you decide to be a physicist?
In those days when I graduated, engineering was essentially repetitive jobs. That uh, was something not very palatable for me. That is how I went in to join BARC. That's how I got into research. And of course, because I got into nuclear energy, so you can't do nuclear energy without understanding physics. I'm not the classical physicist who sort of studies BSc physics, MSc physics and all. See, the important thing is there is something much more fundamental about physics. In the sense, when you ask some deeper fundamental questions, uh, bordering philosophy, you will find there is better connection with physics compared to other subjects. So physics is fascinating. Now, I'm not saying that other disciplines are not fascinating. They are also equally fascinating. But I must also confess here that in school, when I was of your age, no, the two subjects which were most attractive to me were mathematics and physics.
We've all seen these science articles discussing high-end theories and concepts that the average person wouldn't understand. It's interesting to read about, but what do these discoveries mean to us in the real world? Why should you and I be concerned about them?
Well, this is a broader question. You can ask that question at every level between basic research and applied research, for example. Now, there are some discoveries in fundamental research where it's not clear what will be the practical utility. Maybe there will be none, or maybe it will come about, but long time in the future we can't visualize it today. Whereas there are others where you see the practical utility there and then. Now, I am a champion that wherever there is an opportunity to develop benefit to society or people, I think that translation must take place. Whether you yourself as an inventor would want to carry it forward, or you would kind of in a relay race pattern join hands with somebody, and then after the other person is well prepared, hand over the baton for translation to the other person, if that other person is interested in the applied work. So all that should be part of our research ecosystem. So that part is very clear. So I think it's important that you do science for science sake, because the knowledge frontiers have to be moved forward. Sometimes there may not be an application, but that doesn't reduce the importance of that piece of research.
Now, if you were to imagine a nuclear scientist, working 20 years from today, what are some of the things they could be working on? For instance, are there things predicted by science fiction that could come true in the future? Are there specializations we haven't uncovered yet?
Well, the future always holds far more possibilities than the past held in an equivalent period of time, because these are exponential progress phenomena. So, for example, they say that uh, whatever development has taken place maybe in last 100 years, a larger part of has taken place in last 10 years, and so on. So uh, it is no brainer to say that future holds great promise. Now, at the same time, way we have taken the Mother Earth or nature around us, sometimes one wonders whether our very survival is at threat. And there are scientists who have uh, talked about that this may be the last century as far as human beings are concerned. Now, I think these are extremes, and I think the answer to all these problems is in science itself. In the context of nuclear energy, I think we are all concerned about the climate change today. Everybody talks about it. Now, if you look at while there is a huge consciousness, I think there is not enough discussion that has taken place. In absence of emission of carbon dioxide into atmosphere, how do you find our energy needs? Introducing nuclear energy is not so easy because I'm sure moment I said this, in your mind it will flash. But what about Chernobyl? What about Fukushima? Now, war in Ukraine is going on, and the world is discussing whether there will be a third world war and whether there will be use of nuclear weapons. So these are some of the challenges which also need, because these are all important challenges, they need to be addressed. Now, nuclear energy has been evolving. The technology of nuclear energy today is far better than technology of nuclear energy that was there in the past. One of the Nobel laureates, in one of the lectures, he said, yeah, we are producing nuclear energy. Essentially, we are leveraging the fission reaction today. But that fission reaction produces radioactive products. And that is the source of all problem. So he says, can we not search a nuclear reaction which produces energy, that is exothermic nuclear reaction, but does not produce radioactive fission products? And he did point out to such a possibility. I'll come back to what I said. The uh, the excitement in science is also increasing at an exponential pace because the scientific developments are taking place at that pace.
Well, I'd like to carry forward with the point that you made, that nuclear physics as a career has a lot of potential in the future. There's going to be a lot of demand for research in this particular space. Could you talk a bit about, besides the pure research and government jobs, what could be some opportunities in the private sector or even self employment that you should explore if you want to continue physics?
Research can be at various levels. You can do research in your own lab. You can do uh, go up to masters, do PhD, go to postdoc somewhere, and then finally join some university or some research lab or some place. So that's research at individual level, and that's very important. And ultimately, your standing in the scientific community is decided based on what is your individual contribution. So that's very important. Now, as I said, we talked about when there are big questions. Now, these big questions can rarely be addressed on the basis of one person's research. So you create collaborative teams. It is probably too early at this stage, at the stage of 11th standard or first year in college and all. It's probably too early to exactly form your opinion as to what one wants to do. I think slowly you will form an opinion about yourself as to what you want to do, whether it is in a private company or a government lab, or that actually should not matter so much. In each case, you will earn enough money to have a decent living. That is not in question. So, but that's an individual choice. I don't think it is right on my part to influence anybody on that choice. But I can only say that if you are pursuing science, you As you study further, as you get into research, form your opinion as to what is interesting to you. But if you are competitive, then you can always locate yourself in the group where you can pursue your passion, and you will always earn a decent living.
Um, as you look at your own journey, though, as a scientist, um, of course, you have had one of the most inspirational journeys we can ever imagine. Looking back, what would you say has given you the most satisfaction and sense of accomplishment?
I, of course, have gone deep in nuclear engineering or nuclear energy, and there, of course, I have the satisfaction that I can engage in the deepest and most comprehensive conversation with anybody who is in this area, nuclear energy or nuclear physics. I think science is an exciting area to make career in. But as you go further, I think all this should be to address problems in life. Whether these are to push frontiers of knowledge, that also is a problem in life. It's an important challenge before the mankind. Or to develop amenities for better quality of life, or to address several problems of human mind. But the point I'm making is that at younger age, you should go by the excitement of subjects that interest you. As you progress, you go deeper in that subject, but also start looking for what is it that you can do to solve problems around you, leveraging what you know. Some of it you can do yourself, some of you can do by joining hands with others.
Hmm.
So I think the aim is to develop one as an individual to make an impact. After all, when you do science, you write a paper, the value of that paper is dependent on the impact factor. So in the larger sense, you must develop as an individual a good human being and make a larger impact on the society and the environment around you. And the larger the impact you make, you will find higher the satisfaction you get at the end of life.
This is Scienteens, where we meet experts and ask questions that can help you make the right study and career decisions in the sciences. I do this as a fellow student, and your support through a like and subscription will give me and everyone working on this channel a lot of encouragement.